Hello, my name is Malachi Harris. I have been tasked with implementing a new mechanic into this data-driven tile-based game project. The mechanic was originally designed by Ali Reza. Uh, his mechanic is close enemy combat. So basically, what I have done here is that I made some upgrades to my current project. So now I have a title screen and I decided to call my game Shot Block. Um, I don't know, it just makes the most sense. I mean, you shoot turrets and then you kind of block the projectile, something like that. So I do have two buttons. These two buttons do work. So I have a button for the exit screen. If I do click this button, it will exit out of the um, game. And if I do hit play, it will take us to the controls. So basically, it just lay down um, what the player can and cannot do. So we have turret selection, we have reflect reflect, and this is our main ability that I implemented. And then we have movement and attacking. Um, so basically, the player can hold down the F key, um, just basically telling us how to, select objects, and if you release them, something happens. And I basically just tell the player which are enemies, which are destructible, and yeah. So if I hit spacebar, it will take us to our tutorial level. I currently only have one level, um, but yeah. So as you can see here, we do have one turret and we have two destructible uh, cubes or walls. And basically, if the player selects the turret, the player is taught very quickly that that block can be destroyed. So any block in the way of the turret can be destroyed. And we do have our enemy. Our enemy is right here. And our enemy doesn't pathfind to us. The reason why it's because that it can't reach us. So it's just gonna stay still. And once we destroy that block, once we move, the enemy does pathfind to us and it does attack us. So if we try to run away from the enemy, basically it just prevents us from leaving. So we can either attack the enemy or we can use our turret to um, basically destroy the enemy. And we do not currently regenerate health. That was something that I decided not to implement. And so upon completing that tutorial level, it does bring us back to the menu screen. And I'm just going to briefly take you through um, do this level process again to show you that you can in fact melee the enemy. And to melee the enemy, you just simply hit E and then it will play like a little attacking animation for the enemy. I'm going to play this once more to show you that the projectiles does reflect. I'm just going to stop in front of here. So the projectiles I can reflect projectiles towards the enemy. So yeah. Alright, so um, where do we start? So I'm going to walk you through what I have done, um, like the improvements that I made, but also what I have done um, to implement his combat system. Well, the enemies. Alright, so we'll start with the player. So in our player blueprint, we do have a lot of stuff going on. So we do have this ability widget here, and this ability widget, I'll explain more about that. We did add some new stuff to it. So for the health system, essentially I just made a struct that stores the current health, max health, and then the score. The reason why I chose to pass everything within the struct, just to make everything clean and concise, I just simply dislike the fact that I have a lot of variables um, in my details panel, or in my blueprint panel. So we look on the begin play. Me, just basically, I just set the current health to the max health, all the usual stuff. And then I do have a timeline, and this timeline is just here for refilling the health bar, just playing a little animation. And then this set health bar, this is just basically in the abilities widget. So in here we do have our health bar. You may be wondering, how did I get, this rounded border? It was actually quite simple. It's actually a circle. Uh, it's like a material circle. So we go in our materials. We can see just simply a circle. So yeah. And I did, so this is a heart icon that I just picked up off the internet. And then I'd have a progress bar right under there. And the progress bar just essentially fills up, um, letting the player know how much health did they have. And then this is the ability, so yeah. If we hop back to our player, you notice that we do get the actor of we do get the tile map. And the reason why we do get the tile map is essentially we want to access our enemy. More about that later. And then this is just simply setting the health bar, animating that health bar when the player does get damage. More about that later. If we hop into our player movement, as you can see here, I have a call enemy pathfinding. And what that does is essentially get all the enemies that is in the level. And the way that we get all the enemies, we do get that on our tile mapping. And the reason why I decided to get the enemies on a tile mapping and store it on the tile map, it's because there's only one tile map, and it's just simply acting as our singleton class. So we do get an all actors of class, we get the enemies, we do loop over them, and when we loop over them, we just basically give them the reference to the player, saying that, hey, this is the player. Um, Once we are finished with that, we simply um, find a tile. Okay, so yeah, this find tile doesn't need to be here, which is fine. So if we hop into our enemy, we'll take a look at our enemy actor. Yeah, so there's a lot going on. This does inherit it from the interactable actor or class. And this is the old code that Ali provided us. Not really provided us, but this is what he implemented for the enemy pathfinding. For some reason, it wasn't working out. It was kind of buggy. And yeah, I decided instead of having everything turn-based to where when the player moves, the enemy moves one tile forward, I wanted to make things a little bit more dynamic. and a little bit more reactive or more responsive. I decided to go with the algorithm, A star pathfinding algorithm. And what A star does is every tile has an H score, a G score, and an F score. And that is just basically doing some mathematical calculation to basically calculate which tile. It just basically places values on all the tiles in a radius, and then we just simply move to the tile with the greatest value. All right, so you may be wondering why are we even interested in passing our player neighbor instead of the player current tile? And it's very important, very imperative um, that we do pass it an empty tile. The reason why it's because we'll have to we'll run into a lot less issues. It's just best to pass it to a neighbor tile that is next to the player. And we can decide whether or not, and what I mean by neighbor tile just mean in this is a neighbor tile, neighbor tile, neighbor tile. You get the picture. If we open up our function for our pathfinding, so the first thing that we do is we do set our variables. So we have an end tile, which is the target tile that, the destination. We have a start tile, which is the current tile. And what we do is that we first have an open and closed list. So our open list is for tiles that we can potentially traverse through, and our closed list is tiles that we check and it doesn't we don't want to go there. And to show you, and every single tile, I just simply have to. And every single tile, I have added G score, H score, and F score. I added a came from tile, so we are using the tiles as a linked list. If anyone uh, know what a linked list is, essentially it's just that we store a reference to the previous object in the object in a different object, if that make any sense. And everything is linked together in a list. If we go back to our enemy to look more about our pathfinding, we do have a loop. So we go through a for loop, looping through um, all the tiles in the map, and we set the G-score to the negative, like the theoretical negative, I mean, not, well, the maximum integer value, which is +1 than this one. So I set it 1 minus that. We do have a function that we do call. It's called calculate f-score, and the f-score is what we're using to traverse. Um, it's how we traverse through the nodes. We just essentially take g-score plus h-score, and then that will be our f-score. We set our came from tile to our uh, tile that we just basically set all the tile came from tiles to null. Um, just we do this because that what if we call this twice? We want to make sure that we starting from a blank page. We do also set the G-score to 0, and that is for our starting tile. We do have a starting tile and a goal tile. So what we're doing is we're calculating the distance cost, and we sending it to our H cost for our start node. And the calculating the distance, we are taking the X and Y coordinate. So originally I was I decided to not go with having like So essentially what I decided to do was to store references of the tiles instead of having an X and Y coordinate and then simply having a list of tiles and just simply referencing like a double list, like a two-dimensional array, where I would have, the X would be the first index and then the Y would be the second index, or in the two-dimensional array, if that make any sense. What we do is we take the target X coordinate, we minus it by our X coordinate. So essentially, if we want to get distance, so let's say that um, I wanted to get the distance between the add component button and then the interact, we'll simply take the position or the X and Y. So we take the X of this, right, our vector, and we minus it with this. And that will give me the location from the component to this interact um, button or text. And if I want to do that, I'll just swap them around. If I want the distance from the interactable text to the add component button, I'll just simply take the add component button vector and minus it by the interactable text vector. And that is essentially what we're doing here to calculate the distance. And then we are doing an absolute value. We don't really care too much about the negatives. We don't want to deal with them. And we're doing the same thing for the X and the Y. And this is quite complicated. No, it's not really that complicated, but so essentially what we have here is we have a diagonal, um, yeah. So this is basically for calculating the H, like the H score, if that make any sense. So we take our X and Y, right? And our X and Y is just a point. So we take our X and Y and then we minus it. We multiply it by 15. The reason why we multiply it by 15 is because that is our diagonal cost. It's supposed to be 14, but I did 15. Doesn't matter too much. And then we add our straight cost, which is uh, plus 10, and then we multiply this by 0, which is weird. Also, our value is quite interesting. I mean, it works. Wait, yeah. If we go back to our pathfinding, let's calculate the H score. And then we call our method to calculate the F score. Um, Same thing. And then we have a sequence node. I did the sequence node just to keep everything organized. I didn't want to have like a long line, but that's basically what we kind of end up with. So I have a loop, and this loop is just basically saying that if we have any tiles in the open list, please evaluate them. If we don't have any tiles in the open list, we're done. If it's completed, which it should never reach this path unless it's next to a neighbor. However, if it does complete, it means that we don't have any nodes that haven't found any tiles, right? We do calculate our lowest F score tile, and this is pretty simple. All we're doing is just simply doing a comparison operating. We're just saying that we're setting the first index to the lower score. This is something that you should have done in SCD 1. So we're setting the lowest score, and then what I'm doing here is because for some reason I like I'm not going to, I just, well, since I set the first index, zero index, I'm just simply going to skip over it. And we're just comparing the F scores, seeing which one is the lowest, the usual, and then we're just returning. That's it. Mind this up here. We did have an issue with an infinite loop, but um, you don't have to worry about that. If I go back to my pathfinding, we set the F current tile because this is the tile that is the lowest. And I do have local variables. So I check to see is the F current tile is the same as the N tile. If it is, we're just going to simply break out of this loop, calculate our path. What I mean by calculate the path is that since we're storing references of objects or the previous reference of the object in a different tile, we do have to retrieve that. We do have a tile path array, and we have a N tile and then the current tile for variables. So I first put the N tile and the array index. Then I set the N tile to the current tile, and then I just have a simple loop that's just basically retrieving. So the came from tile. So I'm getting the current tile, and then I'm getting a reference to that came from tile variable in our tile, which is right here. And I'm adding it to the path, and then I'm just simply setting that came from tile equal to our current tile, and then so we can just loop over and over until we have it ready. And the reason why I have this, I just simply did a null check. So if we do like end up with a null, we'll just break out of that while loop. And since everything is reversed, we reverse it. So we have our start node at the top and then our end node at the bottom. If it's false, we'll simply remove it from the open list and then we'll add it to the closed list. And then we have a for loop, and this is just basically getting the list of all the neighbors. It's quite simple. Um, it's not the prettiest, but you know, you do it once, never have to do it again. We get the down, add it to the list. If it is valid, get the left, add it to the list, right, add it to the list, up, add it to the list, and then just simply return that list. The reason why I have disconnected the can't enter, we do check for that later in our A star, but that's something that um, I just simply wanted to get down the computational time. Um, but that's something that the A star pathfinding covers. You'll see in a little bit. We first check to see that if it's contained in the closed list. If it is contained in the closed list, we simply don't want to mess with it. You know, if it's in the closed list, just forget about it. If it's false, then we do want to check that if we cannot enter. So if we cannot enter, uh, if can't enter, it's not, which is true. We simply want to add it to the closed list, saying that if we can't enter the tile, don't bother with it. It's just not going to move the enemy to it. Can't do anything about it. If it's false and we can enter it, we'll simply do a calculate distance, and then the goal is our um, next tile that is in front of it. We'll calculate that distance, add it to the traversal cost, which is our G cost. So we add our current tile G cost, and then we add it to the traversal cost. And if the traversal cost is less than the tile G cost, then we simply say that okay, we're gonna make the enemy move to this node, and we'll simply add our previous node to the came from tile, and then we'll set our G score to the traversal cost, and then we also calculate our H score, and then we calculate our F score. And then we have a branch just simply saying that if open score, so if this is like, yeah, so if our tile, it's like if it is in the open list, then we don't do anything. We don't want to add it. We don't want to have like double duplicates. But if it's not, then we'll simply add it to the open list. And then we'll just run this for an infinite loop. Once we're finished, it should eventually reach to our current path. If we step out of this function, we'll have an array of an enemy path. I do have this for loop with a delay. I did went over that in the previous video. And then we'll just simply, so this is quite interesting. I do have a Boolean. This Boolean just basically prevents us from, it just allows us to break out of this loop if we do need to break out of this loop from a different actor. And then this allows just simply traverse to the tile. So, so this is player. It's just checking to see that it's any of the it's the enemy. Like if the player is like in any of the enemy, I mean, it's checking to see if the player is on a neighbor tile of the enemy. And yeah, so the way that we do that is we do call our function that is neighbor, and then we simply have a for loop, which should loop 4 times or even 3 times. It loops, and then it's checking to see is the player current tile is equal to that tile, and then if it is, we'll simply, um, we'll simply break out of this. We'll return. So for our attacking is quite simple. What I have done is I decided to separate my attacking into two. So I'll have an attacking animation um, and attacking animation 2. So our first attacking animation, what it does is it moves our enemy to like in the location of the player to just sell the story that's saying that oh the enemy is actually attacking the player. And for our attacking um, animation 2, it just simply reverses this timeline, um, setting back like it's putting it back to its original location. And we do delay that for the timeline length, and the length of the timeline is 0.2 seconds, our standard delay. And we'll simply just update the player score. So Ali decided to have a random damage. I decided not to do that. Just simply um, set the damage to 2 all the time. So I update our score, and our score is like diversal. So each time you move a tile, your score goes up. So we update our score, and our score is just basically how many points it's deducted from your total score when you kill an enemy. We set our health UI, and if you look back to this is in the player, we'll simply have a timeline. What I have done is I done something pretty clever. I think it's pretty clever. Um, so I didn't want to. I didn't want like I wanted to get the previous health of the player. And how would you do that? You can either do that one of two ways. You can either have a variable that's storing the previous health, so you'll be able to lerp to that previous health from the current health. So you can get that that logic done, or you can either get the percentage of that health bar, multiply it by our max health, and then it returns our previous health. And the reason why this does this, or it works this way, it's because we haven't updated our animation. We haven't updated um, our UI. So yeah, we do have a timeline. We lerp over half a second. Um, yeah. And then we'll set our temp health, and this is our temp health, just here. And then we lerp it to our current health, or like the health. So we're not finished yet. We do have to normalize this, and the way that we normalize it, it's by dividing it by our max health. We'll take that return value divided by the max health, and that normalize it between 0 and 1. We do delay for our time length delay. Our time we delay for the length of the timeline, which is 0.2 seconds. We re-enable. So the reason why we do this is because that we don't want the player moving while the animation is going. Re-enable the player movement. We'll check to see is it dead. If it is dead, we'll simply get the current level and then open the current level to restart the level. And we did, Ellie did put, did had the attacking. So it's just basically the same thing that we've done here. But yeah, I could have overhauled this and then just simply used this, but oh well. For our enemy, I did implement our eye selectable interfaces. So it's just basically change the color to yellow and then change it back if it has been selected or not been selected. And then we just simply include our action, allowing the player to cast Reflect Refract. That is it for our enemy. So some improvements that I have done is I did change the color of the map or the tiles. Right, so if you may be wondering, how did I get those GIFs or animations playing on the video? Okay, so if you may be wondering, how did I get those GIFs to pop up on the UI? They are just videos, videos that have been made into materials, which allows us to, you know, have in a widget. So I have three variables, which are media players, and I call the method open source. I pass in our media source. More about that later. I delay for a little more than a frame, and then I set all of the images. These are images to visible. I do have a timer. This timer just plays this flashing animation for our hit spacebar to continue, or press spacebar to continue. All right, so what I have decided to do is that a lot of people, or some people, they may or may not. In our level blueprint, this is for the menu. I remove all the widgets, and now simply hide the player. I create the widget for our title screen, and then I add it to the viewport, and I set the input mode to UI only. Some people may set the input mode to UI and game, and the reason why I haven't done so is because that I do have button presses. I have button presses, like the F key, controls the cursor. So I simply didn't want that to happen. So if we look into our game mode is where we add our tutorial widget to, we call this method to add our tutorial widget. I'm just basically showing us, and then we do set the focus. And this is very important. Setting the focus allows us to uh, give us the option to register key presses in the widget. So I have overridden this method, and what this method does is on keep down. We get the key, we set it equal to spacebar, so we're saying that if the player hits spacebar, we'll call this method start level, and then we'll just simply return handle. It opens our next level, and then remove this widget from the parent. If we were to go to um, our other map, which is tutorial, save this, open up our level blueprint. In our level blueprint, we delay for a frame, and we set our input mode to game only, and then yeah. And I actually want to see where is this being called. Oh, it's being called in our title widget, which we don't have. But we take a look at our title widget. It is calling that method from our game mode, and then removing it from parent. So we call the other widget, and then we remove this widget from the parent. And yeah, that is basically it for me. So this will conclude uh my implementation. Thank you for watching.